Hello and welcome. Today we're doing a question from LeetCode called container with most water. It is a medium. Let's get started. Given n non-negative integers a1 to an, where each represents a point at coordinate a of I, n vertical lines are drawn such that the two endpoints of the line I is at ai, and I0. So essentially at index I, which if 0, would be ranging from here 1 to 0. At index 1, 8, it would be ranging from 8 to 0, both at the same index. Find two lines which together with the x-axis forms a container such that the container contains the most water. Notice that you may not slant the container. So in our first example here, we see that we have a list of heights 1, 8, 6, 2, 5, and so forth. And we want to output the container with the most water. So how do we form that, right? Here we would output 49 because the max container would be 7 times 1, 2, 3, 4, 5, 6, 7 to get 49. The above vertical lines are represented by array that we are given. In this case, the max area of water, the blue section the container can contain is 49. Here, if we're just given a height of 1, 1, this would be 2 bars with 1. The distance between them would be 1, so we'd have a length of 1 and a width of 1, giving us the area of 1. 4, 3, 2, 1, 4. We would give 16. Since the two ends are both 4, they're the highest numbers we see, we would just do 4 times the distance between them, so index from 0, 1, 2, 3, 4. So 4 times 4 is 16, and 1, 2, 1 would be 2, and here you could probably go either 1 to 1 or straight up 2 just by itself. So before we start, let's look at a few more examples. How are we even finding the area? How are we finding the container with the most water? Well, first we need to be able to find how much water a certain container can store. So if we're given lines of 1 and 7, we have two heights, 2 bars, one of 1, one of 7, and if the distance or length between them is 8, what is our area? Well, we know in any container, we have to take the minimum height. No matter how long we go here, any more water we pour will overflow, so we can only store the minimum height. So this means for a bar of height 1 and 7, we will only ever be able to store 1 unit of water height-wise, and we can do that for 8 units across. So 1 times 8, we would get an area of 8. Now, similarly for bars 8, 7 with a distance of 7 between them, we would do the minimum of 8 and 7, which is 7 times 7, so that would be 49. And 8, 3, and 6. So the minimum of 8 and 3 is 3. And how far can we go storing this 3? That would be 6, so that would be 18. And these are examples straight from what we had in example 1. 1, 8, they were a distance 7 apart, and their container would have stored 8 units of water. 8 and 7, we can actually see that in the drawing here. This is 49, 7 going high, 7 going across. 8 and 3, so this is 8 and 3 from here. So this would have been 3 times 6, 18. And that's how we're going to find the area between any two bars. Now that we know that, how do we find the max area? Area is a length times width, and we essentially want to maximize both numbers as much as possible to get the max area. Well, for the width, that would just be how far the bars are, so indices. We want to start from the indices as far apart as possible. So from the beginning, index 0, to the very end of the array, that is going to give us the max width. Now, another way to do this is also to increase height. So for that is actually very dependent on what bar we have, and our two ending bars, because we can only ever take the minimum of that bar. So how we're going to do this, so we're going to have a pointer at beginning, which will be at 0, 1 at end, so len of height minus 1. We have our two end indices. max area initialized to 0. And from the 2 pointers, we're going to keep calculating the height at both ends until the pointers meet. We're going to keep incrementing them closer to each other. So while beginning is less than end, we want to see whatever pointers our current beginning and end are pointing to, what their area is, and if it's greater than our current max area. So how do we find area? Well, we want to take the minimum of the 2 bar heights, so height of beginning, height of end. Now that we have the minimum, we multiply it by the distance between them. So this times end minus beginning. So this is going to give us the area of 2 bars at indices beginning and end. Now we want max area to be the max of our current max area and this new calculation. And the only other thing to take into consideration here is how to move the pointers up. So if height of beginning is greater than equal to height of end, we increment end closer to beginning. So end minus equals 1, else beginning plus equals 1. And why are we doing this? So we have our 2 pointers, say in this example, at index 0 and 1, 2, 3, 4, 5, 6, 7, 8, at 8. So we have them at 0 and 8, bars 1 and 7 respectively. We know that the bar of 7 has a greater height than 1, but what if we arbitrarily move these pointers? Suppose we moved end minus 1 over here. Well, then we just missed out on this box. We would have had 1 with 3 and then 8 with 3. We would have missed the pairing of 8 and 7. So we always want to get rid of the bar with the smaller height, because what if the next bar is bigger and we can form a greater area? So if this bar is bigger, we want to increment the pointer with the smaller one in the chance that we can find a bigger area. Then when we're over here, which bar is bigger? 8. We can now move our pointer here. Our bar 8 is still bigger, so now we move it here. And if this was just big enough to form a bigger area, that would have been our new answer. But of course we know, since we output 49, this is our answer, index 1 and 8. But this is why we want to move the pointer that has the lower bar height, because that's not what we want for the answer. We're going to miss our real answer if we move them arbitrarily. So once we have that done, we loop through all the way. All we do is return max area. Let's run code. Accepted and submit. And it's accepted as well. So talking about space and time complexities, with space, we are not really using any extra memory, just storing max area, iterating through height itself. So that is constant space O of 1. And for time, we iterate through the entire height list once. We're going from the 2 ends, moving them until we meet in the middle. So that is linear O of n time-wise. If you have any questions at all, let me know down below. Otherwise, I'll see you next time.